Hi. So today we'll go over statistical language modeling. I'll briefly go through some high-level concepts. What is a language model? How do you assign a probability to a sequence? And how do you, broadly speaking, learn such a model? So statistical language modeling is a subset of sequence modeling. It comes from the idea that you can treat a sequence of words, or you can treat a sentence, right, as a sequence of words. I want a burger. I want a burger. So what our language model does is it learns a distribution over sequences of words. Right. So what does that actually mean, right? To learn a distribution over a sequence. So what our model does in practice is it assigns a probability or a likelihood to a text sequence, where more likely sequences, right, a higher likelihood, translates to a sequence that's more reasonable or more fluent. I'll go over two kind of examples of language models to show you what I'm talking about. So let's say you want to learn an English language model or a language model of the English language. What you would expect it to do is assign a higher likelihood, higher probability to a sequence such as yes, please, I would, versus a sentence in a different language like French, right? S'il vous plaît. But these language models don't have to be constrained to something that we think of, intuitively as a language. You can make a language model for something like customers ordering food. Now, what that would do is it would say the likelihood of a sentence such as "I want a burger and fries" would be higher than the likelihood of, something like has nothing to do with food, like "I like jet planes." Right. So the ideal language model is pretty loose. Um, So how does this model assign a likelihood, right? What does it mean when I say the likelihood of a sequence? So think back to your sort of introductory probability or statistics courses to the concept of conditional probability, right? So probability of the sequence A, B, C is probability of C given B, comma A times probability of B given A times the probability of A. The same kind of concept operates here. Right? Let's take one of our example sentences, right? I want a burger. The likelihood of that is equal to the likelihood of the word burger coming after the subsequence I want a times, a coming after the subsequence I want, and then so on and so forth. Want after I, and then the probability of the sentence starting with the word I. So how do you make a model kind of learn this, right? So what you're doing is the model at any given time step, right, any given word point, it learns to assign a conditional probability. So it learns that the probability of the word burger coming after I want a is higher than the likelihood of, let's say, something like train coming after the sentence I want a. So that's kind of the way we learn that is the same way that humans learn how to recognize patterns. We're exposed to a bunch of different patterns that fit the bill, and then we understand what that means. So for an English language model, we introduce it to a bunch of valid English sentences, and it learns that a sentence that's in grammatical English is more likely to appear in that distribution than a sentence in French or a sentence that's in Vietnamese. Same thing with more specialized language models. If we give our language model a bunch of data on people ordering food at drive-ins, it's going to assign a higher likelihood to a sentence such as, I want a burger and fries, compared to some out-of-domain sentence, like I have a fan at home, right? So that sort of concludes our high-level overview of this. If you have questions, reach out to me offline. Thanks.